This is our third video on linked lists, and I think there's going to be one more after this. So previously we talked about the idea about linked lists, and then we talked about adding nodes to a linked list, either at the beginning or the end. So in this video, we're going to talk about deleting a node. And as part of that discussion, we're going to have to talk about searching first. Because if you want to delete a node, you have to find if it's there in the list or not first. So that's kind of where we're going to go. So what I've got here on the screen is just my little, again, I'd rather have a chalkboard to work on this, but this is what we've got. You don't want to have to see me draw with the mouse. That's a bad idea. So anyway, we've got this list here. So head points to the first node, which is a 1. 1 points to the node that contains 5. 5 points to the node that contains 10, and 10 points to the node that contains 25. Okay. And again, the graphs are super helpful when dealing with any of the data structures we're going to cover as a way to help you to reason about what's happening. Okay. If you can't reason about deleting or searching or whatever, then you can't really write the code. And it can be a good visual clue, where does this pointer go? What needs to happen here? Okay. So let's talk about the idea of a search. So when we first start, remember, all we can really see, we have the head pointer that points to the first node. That's all we can see. Okay. We get the info and we get the link, which points to here. Okay. So we're going to start with, again, we can't change the head. We can't iterate through the head or we would lose the whole list. So we're going to start by setting this pointer P. I can get it to move. It's a little bit problematic sometimes. Okay, so P will start off pointing to this first item. Okay. So then we can look to see if, and we have some search term K. Okay, so I won't put that, but let's say K, is 10 in this case. Okay. So we're going to look to see if P info is equal to K, what we're looking for, a search term. Okay. In this case, it's not. Okay, it's 1 and 1's not equal to 10. So we're just going to continue to move this pointer by setting P is equal to P link to go to the next one. Is that equal to what we're looking for? No, it's not. What about this one? Is that equal to what we're looking for? It is. So we return a true. This is a Boolean function. There's no concept in a linked list like there would be with an array of what position is it at. It wouldn't do you any good anyway to know what position it's at. Okay. So that's kind of the idea. So as we're searching through, we want to make sure that we're not, or we just want to know, I guess we're checking to see if we're at the end. If we're at the end and if we can't go any further, then we return a false. Okay. And of course, if the list is empty, we return a false. We always have to check for that. Okay. So let's take a look at what this code looks like. Okay. We'll start with that search. Okay. And skip this for now. I will say that since the last time that you saw this code, I had mentioned that we were going to need to make some functions because we were doing the same code to print and to add over and over again. So I guess we'll start here real quickly before we get on to the search. So here I have a function for print list. Okay. Um, this is going to take a pointer to a node type H. That's the head that we've been doing here. Okay. We're passing this by value. Remember, pointers are just memory addresses, so they don't have the same issue that a class would. Okay, so we don't need a constant here. We should be okay. So because we don't, a print shouldn't change. So for this one, I'm going to create a new reference or a new pointer to a node type called P. Okay, I'm going to set P equal to H, which is this list. Okay, and I've just noticed that I'm not checking here to see if the list exists or not. So I'll probably need to say if H is equal to the null pointer. Yeah, hope it doesn't screw up my code. Just do a return. It's a return just stops execution. Okay, and we don't need an else there because it's going to return if it's true. Okay, so we'll check for that case. And we could print out here. I guess we don't want to leave them there. We want to see out and say that list is empty. Okay. I sometimes forget to check for those conditions, but it's worth checking for. Okay, but if not, the main thing here, we're going to set this node pointer to a node type P. We're going to set it equal to the H, which we're sending in, which is the head of the list. Okay, and then I'm just putting a little goofy line in here for some reason. And then while P, so we're saying while P is not equal to the null pointer, so while there's something there, we're going to see out, I'm just putting a tab, and then I'm putting the info of the list. And then P is equal to P link just moves us to the next pointer in the list. We'll keep doing that until it's equal to null, then we're done. Okay. And then we have the two different adds that we did. So we have the add to back here, a void function as well. This one does take, by reference, a pointer to a node type. So this is our list head we'll send in. And then some integer, it's an integer list. If this were a templated list, this would be our templated variables, but we're doing an integer here, okay? X is what we want to add to it. X is a bad variable name, but what are you gonna do? So I'm just creating, again, a new node, just like the other code we did last time, and our pointer P, okay? So I'm going to create my new node. Okay, I'm adding to the back of the list. So remember, as we talked before, when you're adding to the back of the list, you have to find the back of the list. Okay, so here I'm setting my new node up here. Okay, I'm checking here to see if H is equal to null pointer. So if there's no list H, and then H just becomes this new node. Okay, so I'm adding to the back of a node that doesn't exist yet. Okay, or to a list that doesn't exist. I just added in, no big deal. And also, I'm going to go through and set P equal to H. I'm going to go through, and as long as the P link is not equal to the null pointer, okay, then I'm going to, I could probably say why P link is here, but I just, sometimes it's clearer to put in the full expression, okay? So if it's not equal to the null pointer, I'm just going to keep moving because I don't care, okay? I want to go until I get to the last item in the list, okay? So at this point, I'll be at the last item in the list, and I can set that P link of the last item to the new node, okay? That should add it back in, okay? And then adding to the front is a little easier in some ways. You always know where the front's at, but again, I'm sending it a reference to a node type pointer H and the variable, okay? And then I'm creating my new node type like before, okay? And then I'm going through and I'm checking to see if H is equal to the null pointer. So if H is empty, if there's nothing there, then H is equal to the new node, just like before. It doesn't matter if you're adding to the front or to the back if the list is empty. Okay. So and then, but if not, then I'm going to set my new node link equal to H. Okay, so that's equal to the old list, and then the head just points to the new node. We should be good. Okay. So unless that stuff I added at the top of print doesn't work, that should be okay. So now let's look at this search list. So the search list again is going to take a reference. Do I need a reference here? I don't need a reference here. I don't believe. I'm not going to remove it because I don't want to blow up during this video, but this shouldn't change any for a search. I am going to do that. Be brave. Okay, so we've got our node pointer or our node type pointer H. We've got our search term K. Okay, so again, I'm setting up this pointer as a node type P. Okay, and then if the list is empty, we're going to say if not H. Okay, so if H is equal to the null pointer, we're going to return false because you can't search for anything on an empty list. You can't find anything in an empty list. Okay. Else, we're going to search through the list. We've seen this before, where we're going to set the pointer equal to the first element. Okay. And then while we're not at the end, so while P here, we're going to check to see if P info is equal to this K that we're sending along. Okay. If it is, we're going to return true. Once you hit return, it stops all of this. Nothing else matters. You return true. Else, we're going to keep moving to the next item in the list. Okay. So we're going to go to the P is equal to the P link. Okay. Keep doing that as long as there are elements to go. When we get to the end, if we're still around in this function, we're going to return a false because we didn't find it. Okay. So that's the basic idea for that. So let's go back up here and we'll talk about, I think we'll go back to the drawings, but I do want to be at the top. Okay, so deleting is a little more complicated than things that we've done before with our linked lists. Okay, so let's take a look at the code here. So let's say that we want to delete one of the items. Okay, so we have some cases to worry about here. First, we have to check to make sure that the list isn't empty. If the list is empty, then we can't delete anything from it. So we'll just have to return a message on that. Okay. This will be a void function as well. The other cases we have to worry about is that it could be that we're trying to delete something that's not there. Okay. So in our list now, we have a 1, 5, 10, and 25. If we try to delete a 50, well, we can't do that. So that's where our search comes in. So we will just call up our search function on whatever item we're looking for, in 50 in this case. And if it's not found, then we're going to just say you can't delete this item because it wasn't found. Okay. But if we do find it, we have some cases here. If it's the first item of the list, okay, so let's say we're going to delete a 1. Okay. Head now points here. All we really have to do, we don't need P at all for this one. If we set head equal to head link, now it points to this one and this one is gone. Okay. So that's all we have to do in that case. Okay. So if it's the first item we're looking for, that's all we do. Okay. Now, if what we're searching for is the last item, that's really nothing special. So the other case is it's somewhere in the list, but it's not the first element. Okay. It's all we care about. So let's say that we want to delete 10. Okay. So let me make a note here so we know what we're doing. We want to delete 10. Okay. I check and find that it is there. Okay. So I know I'm not just searching for nothing. Okay. So the head's going to continue to point here at this point. I'm not deleting this first one. Okay. I'll start my pointer pointing to item 1. Okay. And I'm going to say is P info equal to 10? It's not. Okay. So I'm going to move it forward 1. Okay. So I move it to here. I'm going to say now is P info equal to 10? Still not. It's equal to 5 in this case. Okay. I'm going to go to here. Okay. So now I'm going to say is P info equal to 10? And it is. Okay. So we're done with that. But we have a problem because what we want to do, we want to be able to take to get rid of this. We basically want to move from here over to here directly. Okay. It's what we want to be able to do. Okay. The problem is we don't know where this is anymore. We know where head's at. We don't know where this item is in memory. We have no reference to that. So we can't reroute this. We've gone too far. This is very much like trying to saw off a branch that you're standing on. Okay. If your algorithm is climb the tree till you find a certain branch, when you find that branch, saw off that branch. Okay. You can't do that. So what we're going to have to do, instead of a P, we're going to use a couple of different pointers here. That's not what I want. Always get the wrong arrow. Okay, so instead of P, we're going to go with current. That much wider. Okay. So the current's going to go through. So just like we did with the P, when we're ready to go here, the current should point to this. Okay. But what we're going to do in addition, we're going to have a previous. Okay. We have a separate pointer called previous that's going to trail our first pointer. Okay. So the previous at this point, so let's actually go back to the beginning. So at the beginning, we're going to have previous and current both point here. They both point to the same spot. Okay. So we're going to have to test the first record. Is the first record what we're looking for? Okay. It's not. We're looking for to delete 10. Okay. So before we start our loop, we're going to go ahead and move current to the next item. So current points to the node that contains 5. Previous points to the node that contains 1. Okay. Is this what we're looking for? It's not. 5 does not equal to 10. Okay. To move the loop, we're going to move both the current and the previous. Okay. To those positions. Okay. Now we're going to say, does current info equal to 10? It does. Now we're good. Okay. So what we're going to have to do, this line here is previous link. Okay. And the address of the node that contains 25 is current link. So if I let previous link be equal to current link, okay, it's going to take this and point it to there. Okay. Thus bypassing that item. Okay. And that's how we're going to delete things. Okay. So let's take a look at the code on this. And the book doesn't do any of this really. The book has a different approach that we'll talk about a little bit in the next video. But here's basically what we've said. So to delete a node, we have to find it. Okay, so we're going to do the search function. And the things we have to worry about, first is the list empty. Then we have to worry about if the item's not in the list, we can't delete it. We have to worry if it's the first node, and then if it's any other node. Okay. And then this just goes what we'd reasoned about before. If the item's not on the list, we're just going to print out a message and return that we can't delete something we can't find. If it's the first item in the list, we're just going to set the head equal to the head link. That's all we have to do there. Okay. If it's not either of those cases, so if it's not the case that the list is empty or that the item's not found or it's not the first item, we then have to do those 2 pointers, previous and current. Okay. So we'll keep moving those synchronized. The current's always one ahead of the previous. Okay. So we find it, and then we're going to set the previous link equal to the current link, and we should be good. Okay. Let's take a look at the code here. So here's our delete node. Okay. Again, it's going to take, in this case, we're going to actually make a change to the list. So we need a reference to this node type pointer H, which is the head from our program. And then again, an int K, you could call it whatever you want to call it. The K is what we're going to delete. Okay. So up here, I ended up not using a temp, it wasn't necessary. So I've got my current, I've got my previous. They're both set to the head. Okay. We're now making sure that the list is not empty. So if not H, we're going to say list is empty and return, which gets us out of the rest of this entirely. Okay. Case 1 then is that the item's not in the list. Okay. So I'm then going to do this search and say, if not, search HK. So if it doesn't find it, print out that the K is not found in the list and return. Okay. We then have our next case. We're going to check to see if it is equal to the first item. So if H info is equal to K, okay, then H is equal to H link, return, we're done. Okay. So here's the case 3 that's a little more complicated. And I at first thought that last node was a special case. Turns out that it's not. In the list, not. Okay. So if we're here, if we've made it this far, we know that the list is not empty. We know that the item to be deleted is in the list, and we know that it's not the first node. Okay, so we know all those things. If not, we would have returned by now. Okay, so we're going to set current is equal to the current link. We know it's not the found. We know we're not deleting the first item, so we're going to set first time through, current is equal to the second link. Okay, second node. We know that previous is still pointing to the first node, so we're good. Okay, we can now start our link here. So current is going to run out before previous since it's ahead of it. So we're checking to see that current is not equal to the null pointer. If it does, then we're done. Okay. So we're now checking to see if the node we're currently on, if the current info is equal to K. If that's the case, okay, and I don't need a current here. I don't need my temp. I got rid of my temp. Okay. If that's the case, okay, we're on the right one. All we need to do is set our previous link equal to the current link. Okay. And then I'm going to advance both of those. I think I can, we're going to be bold today, make errors, I'm sure. Once I've found this, I can return because I'm done. Okay. There's nothing else I need to do. But if not, if this isn't the case, and I know I'm going to find it eventually, if not, I wouldn't be here, then I'm going to set both current and previous equal to their lengths. So I'm going to move them both. So if I'm originally pointing to 1, if current points to 2 and previous points to 1, if 2 is not what I'm looking for, I'm going to move it so current points to 3, the third node, and previous points to the second node. Okay, it's going to keep those in sync. Okay. And then in my test program, I try to make this test program a little more useful. I make kind of junky ones sometimes, but I think that for homework when you're turning it in, or just when you want to make sure that this is working, then you want to make your test program a little more readable. Okay. So in this case, I'm declaring some node type pointers here for head, new node, and P. Okay. I'm not sure I actually use P in this one after all, but we'll see. So I first start by trying to delete from the empty list. So I'm deleting from the head node or from the head list 5. Okay, that shouldn't give me that should tell me that I can't delete from an empty list. I'm then going to add 5 and then 15 and then 25 to the back of the list. Okay, which will give us 5, 15, 25 as our list. I'm then going to add a 1 and a -5 to the list. So we should have a -5, 1, 5, 15, 25 should be our list. Okay, I'm going to print that out. I'm going to test my search function here. And note, when I was programming this, I certainly tested the search first and then tested each case of the delete on the way, but you're getting kind of the end result here. So I'm going to search for a 5 and then a 55. Okay, so the 5 should not be found. No, 5 should be found. Okay, put a tab in there. And then the 55 should not be found. Okay. The same thing here. For both, I'm doing the found, not found. Okay. I'm then going to delete 55, which is not in the list. Okay. Which should give me a message. I'm then going to delete -5, which is the first item in the list. Print it out again. I'm then going to delete 35, which is the last item in the list to make sure that's not weird. Okay. Delete that, print the list. And finally, I'm going to delete 15, which is in the middle of the list. Okay. Then print the list finally. If all of that, all those changes didn't make a difference. Looks like we're okay so far. And I run this. Okay, looks like we're okay. So again, the first thing I tried to do, I tried to search or tried to delete an item from an empty list. It says the list is empty. Okay. I'm then adding in the 5, 15, 25, the 1, and the -5. So I correctly get the -5, 1, 5, 15, 25, 35. Okay. The search for 5 is found. It's in the list. The search for 55 is not found. It's not in the list. That's working okay. I'm trying to delete 55. It's not in the list. Okay. So the program returns 55 not found in the list. Try to delete -5, which was the first item of the list. It deletes it okay. Tried to delete 35, which is the last item from the list, and it's gone. And then I tried to delete 15 in the middle, and it works as well. Okay. So that's how we're going to delete, search and delete for nodes. Okay. So a little more complicated, little complicated in the sense we have multiple cases of what's going on. I think each step is okay. So again, being able to look at this in the drawing allows us to reason about, well, what could be happening here? What are my cases? What are the cases when we go to delete? So for example, I was thinking maybe it's different if the case, if what we're trying to delete is a last node. It turned out it wasn't, but I only knew that by working through the drawings. Okay. So I encourage you to do that. So this is our next to last video on linked lists, unless I need to do an example from the homework or something. So what remains is the book has a quite extensive abstract data type for linked list that they develop. The abstract data type for linked list has a bunch of functionality, but again, it's an abstract function. They then create concrete, unordered, and ordered linked lists from that. Whole bunch of code there. So I think it's important that you go through and copy from the book. I hate doing that to you in some ways, but I know when I've copied it from the book, so I have a working example of it, it helps me to understand because I'm invariably going to make a mistake and have to fix it and have to go through bit by bit. So we're going to be copying that code over for the abstract data types, abstract data type for linked list, and then the concrete unordered and ordered linked list. Okay. We'll be using those later as we go along. Okay. And then and we'll talk about the structure of that a little bit in the next video. And then the last thing we'll talk about is the two kind of special lists at the end of the chapter on doubly linked lists, where you've got a forward link and a backward link, and then also circular lists, where when you get to the end, you go back around to the beginning. And there's some special considerations for those. Those can be useful. Okay. So that will be in the last video. But if not, that's it for now. Okay. So if you have questions, make sure you let me know. Again, this is our first real data structure that we're having to do ourselves. Not the first one we've used. We've had arrays already, but the first one that we're creating. So therefore, it's important that you understand the concepts here. I will also say that I've got a video. If it's not posted to this course yet, I will, but you can search for it on my YouTube page. I've got a video on how to deal with segmentation faults. These are memory constructs, so therefore you're going to have segmentation faults. And I know I did it a couple times, and it's super helpful to be able to figure out where that memory fault, the segmentation fault, is occurring. Okay, and you can watch the video, but the basic idea is that we do a dash G in our G plus plus line. That G flag will tell it to turn on debugging information. We then use a program called GDB to run it in protected mode and tell us what's happening. Okay, so that's kind of how that works. Okay, so more to come on linked lists, but let me know if you have some problems.